Yeah, good morning. I am Prabha Ranjay, working as assistant professor in EC department at Science College of Technology. In this lecture video, we are going to discuss about the decimation in frequency in fast Fourier transform from discrete Fourier transform unit 1 from the DSP, discrete signal processing subject. Let me discuss. Okay. Already we discussed the DAF is one of the algorithm from the fast Fourier transform. It is a specific implementation of the fast Fourier transform algorithm. In the DAF decimation frequency algorithm, the input sequence is recursively divided in the frequency domain. Let's discuss some of the key point. Okay, divide and conquer approach, similar to other FFT algorithm. The DAF FFT follows the divide and conquer approach. The input sequence is splitted into smaller subsequences, and the DFT each subsequence is computed recursively. Decimation in frequency algorithm. In DAF FFT algorithm, the input sequence is decimated into in the frequency domain, which means the input of the DAF is frequency domain, that is capital X of k, and output of DAF is small x of n. This means that at each stage of the algorithm, each and every other output value of the DFT is selected to form two smaller sequence. And already we discussed the butterfly operation in DIT topic itself. Here also we discussed the core operation in the DAF FFT algorithm is the butterfly operation. Both DIT and DAF is butterfly operation. In each stage of the algorithm, pairs of the elements from different subsequences are combined using complex multiplication and addition. Similarly, twiddle factor, which are complex exponential terms, are used in butterfly operations similar to the FFT algorithm. These factors are pre-computed to reduce computational overhead during execution. Okay, the capital X of k is input of the DAF, and small x of n is output of the DAF. This is the time we know this is the time domain, and this is the frequency domain. DAF, which means we know two input sequence, two output sequence. The one thing is differ between the DIT and DAF, that is the output, first output, upper part of the cross is which is represented as capital A, is equal to just add two input A and B. No involve the twiddle factor, and whereas radix 2 add the one input and multiple product term of the twiddle factor and another input, whereas in DAF just upper part of the class is just add two input, and lower part of the class is just subtract two input, and after that have to multiple with twiddle factor. This is the difference between DIT and DAF. Okay. Also here we have to map the input sequence in flow diagram as per given order. Okay, and take bit reversal for output sequence. same thing, whereas DIT we have the bit reversal for the we have to take bit reversal for the input sequence. After that we map the that sequence, get output for each and every stages. Finally we get the x of 0, x of 1, x of 2, x of 3. Here actually input sequence as per given, we have to map the input sequence as per given order and take bit reversal for the output sequence. This is the flow graph for 4 point input. Don't take bit reversal for the input sequence. We have to map the input sequence as per given order. Take bit reversal for the output sequence. Other procedures same are the same procedure like DIT. Okay, this is the 8-point DFT flow graph for 8-point DFT input sequence and output sequence. This is what let me see what are the difference between decimation in time algorithm and decimation in frequency algorithm. Okay, DIT based upon the decomposition of the input sequence into smaller and smaller subsequence. Here also input sequence here based upon the decomposition of output sequence into smaller and smaller subsequence. Okay, that's why we take the bit reversal for output sequence here, whereas the decimation in time algorithm take the bit reversal for input. In this input sequence for DIT, x of n is split into even and odd numbers samples, we know. Okay, in this output sequence, x of k considered to be split into even and odd number sequence, and third point splitting operation is done on time domain sequence, here frequency domain sequence, whereas DIF frequency domain sequence. And in decimation in time algorithm, input sequence is in bit reversal order while the output sequence is in natural order. Here input sequence is in natural order and DFT should be read in bit reversal order. Okay, this is the difference between both time and some of the applications of fast Fourier transform, that is a spectrum analysis. Okay, yeah, if you have any doubt, comment in the comment section. We will meet in next video. Thank you.